Hello students. So today we are going to start our new subject, which is strength of materials, or in many textbook you will read it as a mechanics of solids. So till now we have in the previous semester in engineering mechanics, what we have learned? We have learnt about the mechanics of rigid bodies. Now in the strength of materials we are going to see about the mechanics of deformable bodies. So today we are going to discuss the syllabus, an overview of the subject. I am Ghanshyam Bhushan, Assistant Professor in the Department of Civil Engineering. So let us see what are the topics we are going to deal. So in the first unit, we have to see about the introduction of this subject overall, how this is going to impact, what are the things, what are the basics of these subjects, where we are going to apply this subject, and a special application to the civil engineering. In the second chapter, we will be focusing on stress and strains. So in the last unit of engineering mechanics, we have dealt this unit, but again we are going to discuss the thermal stress, the stress in composite members, and the compatibility conditions. These things we have not done there, so we will be dealing this in this semester. After that, the concept of compound interest. So till now, like in the previous in the last unit of engineering mechanics, we have dealt with only the uniaxial stresses. Now we will be seeing like two-dimensional stress system, three-dimensional stress system. Okay, and we will calculate the resultant of that principal plane, principal stresses, state of pure, what is the state of pure shear, and what is the maximum shear stress in that condition. Mohr circle is there, and how we are going to apply, and various different theories for theories of failure. So there are few theories like Sand-Benen theories, Von and Moises theories, and so on. So that we are going to deal in detail. Now after compound stress, we will be dealing with the bending of beams. Okay, so what we are going to do exactly, we will be seeing the effect of that bending on that particular beam. Like the simply supported beam is there, and due to like UDL or point load, how the beam is going to be stressed internally. Okay, then we are going to see the point of contraflexure and relation between load, shear force, and bending moment. So these things we are going to deal in very much detail. So this is one of the important chapter, the shear force and bending moment, and the shear force and bending moment diagram. Okay, now let us see what is the fifth chapter. The fifth chapter is theory of simple bending. So here we are going to see the effect of bending. Now we will see what is the theory of simple bending, that is the distribution of bending and shear stress. So if the beam is applied some bending moment or some external moment, the beam will generate normal stress and shear stress. That we are going to see in detail. And what is happen if the direct bending, and what is the effect of bending on combined stress and direct stress. That also we will see, the relationship is there, where that we are going to see. After that, in the sixth chapter, we are going to see about torsion. So bending moment, and it is also a type of torsion moment only, but the difference is at the axis. So if a moment is acting along the axial axis, then it will be termed as torsion. If the moment is along the transverse axis, then it will try to bend the beam, so it will be termed as bending moment. Okay, so elementary concept of torsion is there. One equation is there, same like bending equation we are having for torsion equation also, how the various parameters are affecting the torsion. If like shear stress is there, angle of twist is there, length is there, so one direct formula is there that we will be seeing. And shear stress in solid as well as hollow circular shaft, and angle of twist is there. As I have told you how we are going to calculate the power transmitted by shaft if it is loaded by a torsional force, a torsional moment. And lastly we will see the combined bending and torsion effect, the effect of bending and torsion combinedly. In the 7th chapter we will be dealing with the columns. So columns are very common, you can see in your house or in any of the building. Columns are very much common. So how we are going to differentiate that column, whether it is a short column or a long column, what is slenderness ratio, what is the crushing and buckling stresses, how if the load is axial, how the column is going to behave, and if the load is not axial, that is eccentric loading, then how it is going to act, and the Euler's theory and its limitations. So all the concepts will be discussed by the help of Euler's theory, and we will see where it is limited, where we cannot apply that. Now concept of effective length of the column. After Euler's theory we will see Rankine and secant theory, then middle third rule, core of a section. So these are some detailings that you will be learning in detail, so don't worry much. In the last chapter, that is the deflection of beam, we will be seeing the effect, or how the beam is going to deflect. Various deflection methods are there, slope we are going to calculate the slope and deflection of the beam. If the beam is if the beam is loaded by UDL or UVL or point load, so for different cases we will be calculating the slope and the deflection at particular sections. And what we are going to do, we will be checking the maximum value of slope and deflection. After we are getting the maximum value of slope and deflection, that we will check with the permissible values. If these deflections, that maximum values, are well within the permissible limit, then we can say the structure is safe, or else we have to redesign the structure. Okay, so for this thing we are going to use double integration method, Macaulay's method is there, moment area method is there, conjugate beam method is there, and the application of these methods to the statically determinate prismatic beams. Now let us see what are the assessment tools, how you are going to be assessed for this course. So there will be 2 midterms, so midterm 1 and midterm 2. The combined marks allotted to midterm is 24 marks, and the internal assessment is 6 marks. So for internal assessment I will be giving you the assignment after completion of each chapter, so you have to submit it and I will evaluate it. After that you will be awarded marks, and the end term examination will be of 120 marks. So internal is 30 marks and end term will be 120 marks, so total is 150. So this is all for today. From tomorrow we are going to start your first chapter. So thank you.